So I want us to become a little familiar with some terminology around a radical. So this whole thing is called a radical, and this black part would be the radical symbol. And then we have two pieces that we need to be familiar with in regards to the radical symbol. This little 3 right here is what is called the index of a root, and that tells us what type of root we're taking. The cube root, the 4th root, the 5th root, it can be any number. And then the number underneath the radical is going to be called the radicand. Now, we're going to focus on square roots, so we're not going to have an index there because if there's no index written there, it's going to be a square root, which you're used to seeing. So first, let's just look at evaluating the following radicals. These are quick and easy because they are perfect squares. So we know the square root of 49 is 7, square root of 81 is 9, and the square root of 16 is 4. Straightforward, easy to evaluate. Now, what if I give you a radical that's not a perfect square? How are we going to evaluate it? Well, we're going to work on getting it into simplest radical form, and we're actually going to use our perfect squares to help us do that. So let me go through the steps before we look at some examples. To simplify radicals that are not perfect squares, we're going to find the biggest perfect square that can divide into the radicand, which remember is the number underneath the radical symbol. We're going to write the radical as the product of those two numbers. So let's say it's the 25 and 3, 25 being the biggest perfect square. We'll take the square root of the perfect square, which will come out of the radical, and then the non-perfect square will stay underneath the radical, and it will be simplified.